Hey everyone, welcome to this IBDP MAI HLSL course, and today we are going to start Geometry and Trigonometry topic 3. So this is the first session in this Geometry and Trigonometry, and we are going to learn distance formula, midpoint formula, section formula, volumes and surface areas of 2D and 3D figures. So this topic is very important and is a basic unit of this trigonometry and geometry chapter. So let's start with Cartesian plane. So you already know about the x-axis and y-axis. These are two perpendicular lines which forms a Cartesian plane which divides this whole plane in four parts, and we call these four parts as quadrants. So we starts with this one as first quadrant, and remember we considers anti-clockwise direction as the positive direction. Okay, so angles taken in anti-clockwise direction comes with a positive sign. Angles taken in clockwise direction comes with a negative sign. Negative only shows the opposite direction. For example, if there is an angle, let's say 30 degrees, so I will write it 30 degree. Here, consider an angle, say 60 degrees. So I will write it as negative 60. Why negative? Because negative shows that you are moving in clockwise or the opposite direction to anti-clockwise direction, right? So this is our first quadrant, second quadrant, third and fourth, right? Origin where the x-axis and y-axis intersect each other, and these are perpendicular lines. So if you have a point, say here, there is a point P having the coordinates x and y. So x is called its x coordinate, we also call it abscissa, and y is the y coordinate, we also call it ordinate. Where what is that x and y? See, from the origin, if you have to travel x unit distance along the x-axis, that's your first coordinate, and similarly what distance you are traveling in the y direction comes here as the second part, means your coordinate value. So if you have 2 comma 3, it means you are traveling 2 unit distance along x direction and 3 unit distance along y direction in the upward. Okay, again here negative and positive shows the direction only. So if there is a point in the first quadrant, its both x and y values will be positive, positive. If there is a point in the second quadrant, its x coordinate is going to be negative, right? That's opposite direction. So negative and positive. In the third quadrant, the sign will be negative, negative. And in the fourth quadrant, sign of x is positive and sign of negative for the y. Okay. So now let's talk about the three-dimensional space. So we have one more axis here, x, y, and z, and which divides these x, y, and z, divides this whole space in 8 octants. This time we have octants. 8 parts are there. So this is your first part. You can consider as 8 rooms. Again, we will consider the clockwise direction as the positive direction. So this one where all x, y, and z are positive, this room having this part is the first octant. Here this is first, then just in this room it is second. Vertically opposite to the first one there is the third one, right? So that is the third. Here it is the fourth. Now we are moving in the anti-clockwise direction. Similarly, just below to these we have another set of these 4 rooms. We can call them as, again, starting with 5, then 6. In the same way, 7 is there and this one is 8. So we have octants in this way. Again, the point of intersection of x, y, and z axis is this one called origin. All x, y, and z axes are perpendicular to each other. In this case, the coordinates of a point is represented by P, say x1, y1, and z1, where x1 is again called abscissa, y1 is the ordinate, means distance traveled in the y direction, we call it ordinate, and z1 is applicate. Okay, now that was the introduction to the Cartesian plane. Now let's talk about the distance, midpoint, and section formulas. So consider 2 points having the coordinates x1, y1, z1 and x2, y2, z2. These are 2 points and we are trying to find the distance between these 2 points. So when we connect these 2 points, yes, there is a distance formula also, which is given by taking the square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Like this, right? So that's the distance formula. If all the values are given to us, we can directly plug in those values here and get the distance between any 2 points. If it is in two-dimensional plane, then you can ignore this part as well as in the solution as well, right? Hmm. Now, for the midpoint formula, consider there is a point which is lying in the center or the middle of A and B here. Okay, so the coordinates of this C will be given by taking average of the coordinates of A and B. So just take the average of x values, means x1 plus x2 over 2, y1 plus y2 over 2, because it's a midpoint, so just take the average. Now, the third one is the section formula. Means let's consider there is a point, okay, which divides the A and B in some ratio called m is to n. So let's consider that D point is dividing this AB in m ratio n. Means A to D is m distance and D to B is n. So in this way you can say D is dividing this AB in m ratio n. If it is internally, so D will lie between A and B. If it is external point, then either it will be here or it can be on that opposite side. Okay, so internal and external division in that case. So the section formula is given by this one, mx2 plus nx1 upon m plus n. Similarly, for there is a symmetry. For y coordinate of the D, you can use my2 plus ny1 over m plus n. Similarly, for z coordinate of point D, we can use mz1 z2 plus nz1 upon m plus n. So we can find the distance. Let's solve a problem here. So consider 2 points P and Q, and their coordinates are already given to us, 2 minus 4 minus 6 and 4 3 minus 1. So here we have x1 as 2, y1 as -4, z1 as -6, right? So in the same way for Q as well. Now for finding the distance between these 2 points. So let's find the PQ value. So the PQ will be given by, plug in those values here. Okay. Yes, it will be square root of 4 minus 2 whole squared plus 3 minus of minus 4 whole squared and then -1 minus of -6 whole squared. After simplifying these, it comes out as 8.83 units. Next, let's talk about the midpoint of PQ. So we are already given the coordinates of P and Q. Okay, so take the average of x values, means 2 plus 4 divided by 3 minus 4 plus 3 divided by 2, -6, -1 divided by 2. So take the average only. That gives us x value as 3, y value as -1 by 2, z value as -7 by 2. Now, third part, coordinates of the point that divides P and Q in 3 ratio 2. So this time there is a point, let's say here, this point divides PQ in 3 ratio 2, 3 is to 2. If this is given as positive, it means internal, right? So now use the section formula. Here you can see M is 3, N is 2, and already we know the values of coordinates. So just plug in those here and we will get this one. You can try it by yourself and you can verify your result with these values. Okay. So now, so we learned what is the distance formula, midpoint formula, section formula, and its geometrical meanings. Okay. Now we are done with this part. Let's move to the second part of this, which is volume and surface areas. So you are already familiar with these formulas of surface area and volumes, right? Let me tell you something. Surface areas, for that, for finding the total surface area, what we can do is we need to find the areas of all the faces. Okay. So if they says find the surface area, just calculate the areas of all faces and add them up, right? all faces. If they ask for curved part only, then we will calculate only curved part. Okay. So for example, consider this cylinder. If they say is find its lateral or the curved surface area, it means this portion, the cylindrical portion without top and base. So that comes out as 2 pi RH. But if they say is find the total surface area or simply surface area only, okay, then again you have to use the total surface area formula, which is what? You have to take the curved part plus top as well as bottom. Both top and bottom are circles, right? So we can add the 2 times pi r squared area, which comes out as this 2 pi r times r plus h. So in this way you can calculate the surface areas. Next is volume. For volume, it means the amount or the amount of water it can hold, or the capacity of that solid is volume of that solid. So again in this case, if you have uniform solids like these, right, or the cylinder, then you can just take the base area, multiply it with height, gives you the volume. Okay, base area times height. But if you have in which there is a constant increase or decrease in the base, right, like the cone or like the pyramid, okay, pyramid. So in these cases, the volume is given by 1/3 times base area times height. Okay, so remember this thing. So it's very important to memorize these formulas of volumes and surface areas. Let's solve some questions. It says find the volume and surface area of the sphere of diameter 16 centimeter. So diameter is given, we will convert it in the radius. So radius is what? Half of the diameter. So we got r equals to 8 centimeters. So consider a sphere and its volume is to be calculated. We know the formula is 4 by 3 pi r cube. Just plug in the r value as 8 here and we will get our answer. Okay. Now, after simplifying it, you will get 2144.66 centimeter cube. Similarly, we can find the surface area, which is given by 4 pi r squared. Again, plug in the value of r here, right? And you will get the surface area value, which comes out as 4 pi times 8 squared, means 804.248 centimeters squared. In case of a sphere or the circle, we have only radius, right? Okay. Next one is, let's talk about this one. We have to find the surface area and volume of a square based pyramid. Okay, square based pyramid. So we will have a square based pyramid. Its base will be a square. Let me create the square base for you. So if it's a square base, now construct a pyramid, means taking these, join them on the top. They meets at a point. So in this way, it's your pyramid whose base is square. Remember this, right? This. Side lengths are already given as 5 and the height means from this top to, if you drop a perpendicular on the base, that height is given as 9 centimeter. Okay, so this is the figure. Now in this problem we have to find the volume. So volume of the pyramid is given by, as I said, 1/3 of the base area times height. So we have 1/3, right? B is the base side. So B, what is B here? B is 5 here, and height h is given as 9 in the centimeter. So yes, we can get the volume of the pyramid in this way. 1/3 base area, it's a square base, right? That's the answer. Now for the surface area. For the surface area, if you see, what is that? There is a base area as well as 4 faces, triangular faces. Okay, so I will take the base area, which is a square. So B squared is the area of base, plus 4 times the faces. There are 4 faces and all are triangle. So we know the area of triangle is given by half into base into height, right? So half into base into height. Let's talk about these. Base, yes, we already have the base, this one, which is same as the any other side of the square, right? Which is 5 centimeter in this case. Now the next part is, what is L? L is what? Height of the triangle. Can I take height as this h height? No, it's not the same. The reason is this h given, which is 9 centimeter, is the height from the top point to the base, right? It's a perpendicular to the base. It's not the height of this triangle face. So for that triangular face height, we need to join this point here. So let's call it A, B, C, D as the base of the pyramid. There is a point E and this point is F. So EF is perpendicular to the BC, and yes, EF is the height part for that triangular face. Now we need to find the height part. So can you consider this part? Let's join these. Let's join these, and F, let's call this G. Okay. So consider the triangle. This is the triangle G, F and E. We are looking for EF distance. We are already given GE distance, which is 9. What is GF distance? Yes, it's very easy for us to calculate GF also. This G is at the center of this square, right? So from G to F, it is nothing but half of the side length. So GF is 5 by 2. Now it's a right angle triangle. Now I can use the Pythagoras theorem to calculate the value of EF. And hence, once we get the length LEF, we can plug in that value in the half into base into height formula. Okay, so let's use this. So we know we have to look for this height. So which is given by the Pythagoras theorem. Okay, from this point to this point. So given by square root of 9 squared plus 5 by 2 whole squared. Now you have everything. Just plug in these values either in your calculator or do it manually, and hence you will get your surface area as approximately 118 for 3 significant figures. Okay, that's it. Now consider this problem. It says a grain silo is formed of a hemisphere on the top of a cylinder of radius 5 meter and height of is 30 meter as shown here. Height of the cylindrical part is given, okay, which is 30. It's not the height of the total silo. Okay. Now it says here height is 30 and the radius is 5. So that is also the radius of spherical part, 5. 5. Now, in order to find the volume of silo, what we have to do? We have to add the volumes of this cylinder as well as the hemispherical top. So, in this case, we have this cylindrical base and on the top of it, we have this hemisphere. So, we will add up the volumes of both of these, right? So, we are combining these two solids. We have the volume of the silo given by the sum of volume of sphere, hemisphere, as well as the volume of cylinder. Okay. So, what we have now? Volume of hemisphere, we already know the formula 2 by 3 pi r cube, and for the volume of the cylinder pi r squared h. Just plug in these values because r is already given as 5 meters and height h is already known as 30 meters. So, we will get our volume in this way, right? So, after simplifying it, it comes out as 2618 centimeter cube actually. It's meter cube. Everything is given in meters. So it is meter cube. Okay. So now we have learned how to find the surface area and the volume of the solids for those solids which have the uniform base, right? And curved part also. Then we have seen how can we relate these things to combine two solids, and if in any solid one side is missing and other informations are given to us, yes, we can find the missing side also using the information, right? So yes, we have completed these things, right? So now the next part, as I said, in the next part we will see how to find the angle between two lines or one line and plane. Okay, let's talk about this. So if there is find the acute angle between these two lines, y equals to 4x minus 3 and y is equal to 5 minus 3x. So first of all, we need to find the slope of these lines, because the formula for finding the angle between two lines is already given in your handbook. You can use that, which is given by tan inverse, taking the modulus for finding acute angle, m2 minus m1 over m1 1 plus m1 m2. I will use this. Okay. So in order to apply this, I need m1 and m2. What is m1? Slope of this line. So we know the y is equal to mx plus c is the slope intercept form, where the coefficient of x, which is m here, m represents the slope. So for the first line, what is the slope? Yes, 4. And for the second line, the slope is negative 3. Okay. So the slope of the first line is 4. Slope of the second line is negative 3. Now plug in these in the formula, right? I'm using modulus. See, there are two angles between two lines. This is, let's say, theta. So this angle is going to be pi or minus theta in radians, or you can say 180 degrees minus theta in degrees. Okay. So I'm taking modulus, that will give me acute angle directly. So plug in these values, and either you can use your calculator also. We got tan theta is equal to 7 by 11. So theta comes out as tan inverse of 7 by 11, or we also call it arctangent of 7 by 11. Plug in this value in your calculator, GDC, you will get your answer in either in radians or the degrees. Okay. You can check your calculator whether it is set to give you radian measurement or the degree measurement. You can change anytime. Okay. Now, next problem is, it's very important one. A storage container is made in the shape of a cuboid. It has a width 2, the length 4 meter, and the height is also 2 meter in this one. So it's a cuboid. Now George wishes to store the mass from his boat in the container. The mast is 4.6 meter long. Okay, so length is going to be this one. So it says the base of the mast is placed at B and the top of the mast is placed at point D. It means from this point to this point, like this. This is going to be the base of the mast. Now, in this question, what they are asking for, first part they says find the length AD. And the second part, this is find the angle must mix with the floor. It's very important. In this way, we are trying to find the angle between this line BD and the plane base of the cuboid. Okay, so let's start with finding AD first. What is AD? AD is, this portion is AD, right? And as you can see, the triangle BDA is a right angle triangle, right? Now, if we have any two side lengths, we can find the third side length easily, right? So what is BD? Which is already given as 4.6, right? Now the thing is, what is BA or the AB? AB is diagonal of the base of the cuboid, right? And again, this triangle ABC is a right angle triangle, right? We can use the Pythagoras theorem. AB is the hypotenuse of that. So I can use AB squared is equal to BC squared plus AC squared. So from here I can get the value of AB. Once I have the value of AB, I already have the value of BD. I can again use the Pythagoras theorem in the triangle DBA to get the value of DA, right? So that's the approach to solve this question. Second part is find the angle must mix with the floor. There are several ways to calculate this. See, we already have the all the three side lengths in the triangle DBA, and we are looking for the angle must mix with the floor. Means this angle here with the floor, or I can say the same angle, angle B in the triangle ABD, right? So we can use the trigonometric ratios to calculate this angle. Let's do it. So as I said, consider the triangle ABC and let's find the AB, which is hypotenuse of that right angle triangle, which comes out as AB squared is equal to 4 squared plus 2 squared 20. So AB is root 20. Now consider the triangle ABD. We got AD by using the again Pythagoras theorem 1.08 meters. That's the value of AD. Now, second part. Consider this angle as theta. We are looking for this value. Now, in the triangle, we are already given all the three sides. So, you can use either sine theta, cosine theta, or tangent theta. That's totally up to you. So, if I use the cosine theta, what is cosine? So, ka, toa. So, it's adjacent over hypotenuse. So, adjacent side is this side AB over hypotenuse, which is BD. So AB over BD, which comes out as square root of 20 over 4.6. Now again using the arc 10 or sorry arc cosine, right? You can find the value of theta. Either in radians or degrees, you can convert it as I said earlier also. Okay. So now in this session, we have seen how to find the angle between two lines, angle between line and plane, and angle between two intersecting lines also in the 3D, right? So this is a homework question for you. You can try this question all by yourself, right? So I'll see you all in the next session. Thank you for watching this. Keep watching, keep learning.